Hi guys, welcome back to my another video. This video we are going to talk about network endpoint groups (NEGs). So we are continue to follow and exploring the load balancer with the unmanaged instance group, and then we have covered the managed instance group, and now we will see what are the network endpoint groups. You must have seen this option while you creating the load balancer and the backend service. When you choose the backend service type, you must have seen this option network endpoint group. So whatever demo we have covered in our earlier videos, we have covered with the instance group. But this video is going to be focused on network endpoint group. So in this video, we are going to talk about what are the network endpoint groups, what are the types of the network endpoint groups, and why do we need use network endpoint groups in what scenario the network endpoint group is useful. We'll also try to cover a demo with the VMs and with the Kubernetes cluster and with different use case. Okay, so let's first understand what is the network endpoint groups. So network endpoint groups is nothing, it is a group of your endpoints, right? So network endpoint groups contains a network endpoint. Now if I say the definition of network endpoint groups, so a network endpoint group is a configuration object that specifies a group of backend endpoint or a service, right? So if you use NEG with the Google Cloud Load Balancer, it can serve VM instance group workloads and serverless workloads and containerized workloads. Um, Network endpoint groups widely used with the Kubernetes cluster because of some limitation with the instance group. So that's why the network endpoint group has been introduced. So I'll explain it later why we use network endpoint group. So let's understand network endpoint group with some example, with some diagram. So if you look at this diagram, let me just zoom it. So on my left hand side, this is a typically a load balancer or a typical way that load balancer distribute and balance the request across the instance, right? And on your right hand side, the load balancer is basically redirecting the traffic to the network endpoint groups. So typically a load balancer will front end a group of similar service running across different physical or virtual machines and distribute the traffic based on the load distribution algorithm, right? Sometimes round robin or maybe other way of algorithm. So these load balancer assumed a service per instance, which was true until the age of containers. But now containers and container based workloads change the notion of how application services are run. So an entire application service can be packaged as an image and run anywhere by listening on a specific port. And also multiple instances of a container based service can be scaled to run on same instance. As container based workload gained a significant popularity and adoption over the years, it is a very essential to support this concept of scalable application service listening on a port irrespective of the instance they are running on it. So network endpoint groups were introduced to represent a group of scaled service listening on a specific port. And if I talk in short, NEG enables us to take a leap from instance-based load balancing to a service-based load balancing. As you can see on your right-hand side, the load balancer traffic is directly going to your network endpoint group, and from network endpoint group, it is directly sending the traffic to the port. So it is basically bypassing your instance, right? It is bypassing your instance and directly sending the traffic across your pods. So these network endpoints are typically configured as a group of scalable service behind a load balancer so that they can reach via single endpoint. Also these network endpoint groups enable service running outside, let's say on premises or different cloud provider, to utilize the superior capability of the Google frontends and CDN network. All right, so this is the basic difference. Um, and there is one more difference which we wanted to explain. When on your left hand side, in this picture, um, the client reaches the Kubernetes service and then sent out to your backend instance. Okay, so the traffic is again hopping over to the VMs, and then the queue proxy service running in the each nodes redirect the request to correct the pod via IP table rules, right? So that's why there are multiple hop counts and there are less hop counts. Okay, so let's understand the different types of NEGs in the GCP. So first we have the zonal NEGs. So these are the NEGs for the service running in a VM within a zone, and also GKE pods. Internet and NEGs is used to access the backend outside of the GCP from the Google Load Balancer. And we have the serverless NEGs, which basically enables serverless service such as a Cloud Run or Cloud Function, as a backend to the Google Load Balancer. Hybrid NEGs allow you to configure services deployed in on-premises as a backend to a to your Google Load Balancer. And then we finally have the Private Service Connect or PSC NEG, which configures service running across networks and projects as a backend to a Google Load Balancer. So we will talk about, we will see the demo on journal NEGs. We will see some demo on serverless NEGs and Private Service Connect NEGs. Hybrid and internet we are not going to cover because this is outside of because this is something that your backend is going to be located on some sort of on-prem or other outside of the Google Cloud. So let's understand some of the use case if you want to connect to multiple GKE ports directly, which is zonal energies for GKE. So let's come back here. I have one more diagram which I wanted to show you here. So this is the use case one. Basically, we are saying connect multiple GKE ports directly. Okay, so here um, this this particular diagram, let's understand this diagram. So in Kubernetes, a service exposed a set of pods providing a specific functionality on a specific internal IP and port, right? So these pods belonging to a service, right? These pods are belonging to a service and can be scaled up or scaled down, and then typically run in a GKE cluster nodes, right? And these services essentially act like a network load balancer and route requests to a multiple ports connected to it in a specific, maybe a round robin or weight based fashion. A typical Kubernetes service routes inbound requests to pod in two hops. So the request is initially sent to the underlying VM nodes and in a GKE cluster, which again use kubeproxy to route the request to a specific pod running on under this service, right? So to connect a specific pod, exposing the application functionality has got two hops, right? The service to VM and from VM to pod. So this is the flow of request. The client is sending the request to the service, and the service and then sending the request to the your VM, and from VM the key proxy look for the IP table and send it to the pod. So this is the way. So in this picture, you can see that the key proxy service running in each node redirect the request to a correct pods, right? Now let's talk about the NEGs. How NEGs? If we introduce the NEGs, so this is the picture I have. In this diagram, if you look at this, with NEGs, the pods, you can see the pods are directly exposed by the pod IP and port. And in this case, the client communicate with the ports directly without contacting the queue proxy within each nodes, right? So this will result in lower latency and better performance, right? So GKE automatically manage the network endpoint as you scale up and scale down the underlying ports. So new endpoints are added to the NEGs during scale up, and existing endpoints are removed during the scale down. So you can see that, right? The difference here. The difference is that here the hops are going to reduce here when we use the NEGs. Okay, to and if you want to expose your Kubernetes service as a NEG in your GKE cluster, you should use an annotation um, uh, uh, while exposing the ports in your YAML file. I'll explain it when we cover the demo. Okay, so let's see in action how endpoint groups can be deployed. We will first create a simple you know network endpoint group which will be having one or two VMs, and we will try to expose it to the outside world. Okay, so let's go to my Google Cloud Console, and here let's create a VM. I'll take it web one. I'm going to expose it on my VPC one. Let's change the region nearest to me. I'm also exposing with the external IP address. 1 second. Starting a script. All right, everything looks good. Let's create it. So this time we have created a web one instance where we have deployed an HTTP server, Apache, and then we are going to this time we are not going to use the instance group. We are going to use the network endpoint group. So for network endpoint group, maybe so here is the network endpoint group. So let's create an endpoint group. Let me first delete this, otherwise you're gonna get confused. Create the network endpoint group. Saying it's my network endpoint group. Just name it anything. Choose your VPC. See, this time I'm going to use journal. You can have a multiple option here, but I'm going to select this journal, which is widely used. Okay, subnetwork and the zone. Okay, what zone my machine was deployed? So you have to make sure that whatever instance that you have to, going to deploy, you have to choose the same zone. So it's Asia South to A. So you have to choose this one. Default port is 80. 80. Normally, we don't use network endpoint group with the VMs. I have seen that. Um, because you don't want to distribute the traffic with the network endpoint group to your VMs, because your VMs is not having any containers, right? So every VM has this web servers running, and you want load balancer to redirect the traffic based on different algorithm, which is fine in this case, right? But just to show you the demo, I'm going to choose this network endpoint group so that you understand as why we can use the network endpoint group in case of the instance group as a backend service. But typically network endpoint group is widely, and in the real world you'll see the network endpoint groups is widely used with the Kubernetes cluster. So it is more or to solve the network complexity problems in the Kubernetes. So okay, so now let's go to your load balancer. Create a load balancer. I'm going to select the global one. So I'm going to make it my GLB FE80 done. So here now I'm going to create my backend service one, and here I am now going to select up 1 second. So okay, so backend type. Now the backend type I'm going to select a zonal network, right? So now you'll see your network endpoint group is available, And here you can see 100 requests per second per endpoint. Done. Don't need CDN. Health check is required. I'm gonna make it default and create it. So you can here review and finalize your, you can see that your front end is listening on port 80, and this is your backend service. And but your backend time, this time your backend type is not your instance group, but this is the endpoint, the network endpoint group. Okay. It's going to take a while. Okay, so I'm gonna pause this video. I'll come back after 3 minutes once my global load balancer is completed. All right, so it took 3 minutes to complete the load balancer deployment. So you can see that my load balancer, my GLB has been deployed. The balancer type is application. The protocol is HTTP, and it has got a one backend, which is uh, this time you can see the one network endpoint group. So this time zero instance group. You can clearly see that, right? So if you try to hit this IP of this load balancer, you should be able to access. Let's see that. No healthy upstreams. All right, let's check it. Did we have we done something wrong? My backend, the healthy. Oh, zero of zero. Why zero of zero? Okay, so I forgot to attach my VM under this network endpoint group. So you have to add the network endpoint. So you have to understand this concept. You first create the network endpoint groups, and under this network endpoint groups, you must need to add the network endpoints. So the network endpoint is going to be your VM, or it could be your pods, and it could be your serverless machines, right? It could be anything, right? So you gonna need to add this. Select your VM, and I'm going to say let's remove this, or it is required. I don't know. Let's take it. Let's take the IP. Okay, I don't need 6 default, and let's create it. Okay, now if we look at our load balancer, this time it should work. Okay, so you can see that one of one. I know your network endpoint groups has got one network endpoint, which is a VM. Now if you try to hit this, see, the moment I added my VM as an endpoint in the network endpoint group, my load balancer is able to send the traffic to the network endpoint group, and the network endpoint group is now forwarding the traffic to this VM. All right, so this is how you can use the network endpoint group when you want to send a traffic to the VM. But most of the time we use instance group. So typically, I'll show you one use case where you use both, right? The pod and the VMs, right? So I have an image here. If you look at this image, so this is a use case where containers and VM based backend for similar service. We call it journal lake. You can see that here journal lake um, enables a set of application running in VMs to be exposed as a group of endpoint behind the load balancer. So let's consider the case where you are transitioning from VMs to the containers. So in this case, some of your application will be containerized, while some of the application may continue to running in the VMs. So you could use zonal VM based network endpoint groups to add VMs, and GKE container based network endpoint groups as backend for Kubernetes pods. And with this, a single load balancer can now serve your VM based workload and your container based workloads, right? So this is the one of the use case where you can use both as a network endpoint group, right? So I think that's it for today, because this is going to be a longer if I cover the other demo. So what we're gonna do? Let's I'll come up with the with the another video on how to deploy network endpoint group as a to forward a traffic to your pods in a GKE cluster. So what are we going to do? We'll deploy two cluster. The first GKE cluster is going to have the network endpoint group as a node, and the second the network endpoint group we will deploy as a pod. So we'll see the difference, and we'll see and we will send some request to both the cluster, and we'll analyze the request, like how this is going to reduce the latency and improve the performance in a real time when we see in the monitoring analysis. All right. So I think that's it for now. We'll see in next video. I hope you enjoyed this video. All right. So thank you. Have a great day. Bye bye.